All right, let's do electric field, please. I said definition, please. Electrical field is that's E. By definition, electrical field is simply a region of space where a charge experiences an electrical force. A region of space where a charge experiences an electrical force. That's all. Next up, please. Let's consider this. Let's consider this, please. I think this should actually be the E itself. Let's look at electric field intensity. Let's look at electric field intensity. Electric field intensity is also called the strength of an electrical field. Please, the word intensity means strength. Electrical field intensity is also called the strength of an electrical field. Full stop. It is the force per unit charge. It is force per unit charge. It is force per unit charge. It is force per unit charge. So I say that mathematically, electric field E is equal to force all over charge. Force, of course, in Newton, charge in Coulomb. So the SI unit for this man is Newton per Coulomb or volt per meter. Please take note. For electric field, it has two units. Majorly, it's Newton per Coulomb. Sometimes it's volt per meter. When we talk about what is called electrical potential, now include, so these two, there are two units, all right? Newton per Coulomb or volts per meter. Full stop. Take down, please. Take down, please. Given a charge, capital Q, given a charge, capital Q, distance at R meter. Given a charge, capital Q, distance at R meters, distance at R meters from a test charge Q naught. Distance at R meters from a test charge Q naught as shown below. You can sketch this. Given a charge capital Q, distance from a test charge Q naught, distance at R from a test charge Q naught as shown below. You have this. Then from Coulomb's law, the electrical field E, then from Coulomb's law talks about the force of attraction or repulsion, right? Then from Coulomb's law, the force between the charges is given by F equal to K Q naught all over R squared. We said product of the charges and then inverse of square of distance. Call this your first equation. So this from Coulomb's law. But then the electric field at this point here, but we said electric field is equal to force all over charge. So I'm considering the test charge now, it becomes force over charge. So I'm having this. If I substitute value, I'll have that electric field, that's E, is equal to force, that's Q naught all over R squared. That's the force is now this. We said E is equal to force divided by charge. The force is now all of this. I will now divide this by charge. It becomes force over charge. These are the same thing. Force is this divided by charge. Of course, to simplify this, this becomes E is equal to K Q naught all over R squared. We have to change the word there, multiplication. For this one, I'll invert it. That's how I work on fractions. So if I invert, it becomes 1 over Q naught. From here, this will cancel this. So you have that the electrical field intensity E is equal to KQ all over R squared. So I have this. All right, so I have KQ over R squared. So this is how this is done. So observe that it's this one, electrical field and what's it called, and force are almost the same thing. The difference is that for force I need what there? 2 charges. But for this one I need just 1 charge. Also, but from our last class, what we did, Coulomb's law, we said K is equal to what there? 1 all over 4 pi E naught. We call this the permittivity of free space. If I put this value here, it means that E is equal to, this is K multiplying capital Q all over R squared. But K we said is this. So I'll replace K by this, and that will be equal to, so replace K and put this, I'll be having 1 all over 4 pi E naught, that's K, times this over this, Q all over R squared. So that means E is now equal to 1 times Q is Q all over this one here, this becomes 4 pi E naught R squared. Please, this formula or this formula works for electrical field. So the formula for electrical field is E equal to K Q all over R squared, or this one. These two, they mean the same thing. How did I get this? This is a constant from our last class. Think about this. It's a constant. 1 over 4 pi E naught. It's a constant. It's always that. So I have this. We'll take a sample question. We'll take last year's exam questions. That's what we'll do. We'll take a sample question. We'll take last year's exam question and we'll proceed. Okay. Example. Example, if you're done. What is the electrical field intensity? What is the electric field intensity at a point P? What is the electric field intensity at a point P? 25 cm at a point P, 25 cm from a charge Q. What is the electric field intensity at a point P, 25 cm from a charge Q, equal to 80 nanocoulomb? This way, please. Equal to 80 nanocoulomb. Full stop. That's all. Full stop. All right. So solution there. Most likely, for most persons, they will not draw diagram. It is the little things that matters when it comes to exam. Little things. So a person just come here and say, okay, they've given us Q, they've given us R, let's just start solving. No, please. In your own, try to put in a diagram. How do you put diagram? As simple as this. My first task will now be, we said a point P. So I'll just from here, I'll get somewhere, just draw the line there. Call this point P. We said P is how many, what distance there? So from here to here is 25 cm. So P, 25 cm from a charge Q. Q is how many again? So 80 nanocoulomb. It's as easy as this, please. All right. This is a point P. Let me call this small p here. So P, 25 cm from this. So next task, list out given parameters. What am I given there? Number one, I'm given a distance, that's r, as equal to 25 cm. I would have to convert to meters by dividing by 100. So it becomes 25 all over 100. That's equal to 0.25 meters. I've done my conversion. Next up, number two, they said from a charge Q, the value of Q there, they said is 80 nanocoulomb. So it becomes 80 NC. Of course, nano is 10 to the power minus 9. So it becomes 80 times 10 to the power minus 9 coulomb. From here, I now say recall formula. So recall that we said electrical field E is equal to KQ over R squared. K is a constant. 9 times 10 to the power 9. So it means that E is equal to, this one is always a constant. So whether you're given or you're not given, it's a constant. That becomes 9 times 10 to the power 9 times Q. That's 80 nano. So 80 times 10 to the power minus 9. KQ all over R squared. R is 0.25. So I have 0.25 R squared. Please punch everything. What's your answer? Please punch everything. What's your answer? When you are punching, please punch, so that you make the mistake. I will correct you now. What's your answer? What's the answer, please? 11520. Just this? All right. Units, please. Newton per coulomb. So I have this as Newton per coulomb. So this is how this man is done. That's how this one is done. So it's just KQ all over R squared. That's it. I'll do example 2. I'll use to explain something and then I'll do the test question. Example 2, take down. Two charges. Example 2, take down. Two charges, 4 microcoulomb, and two charges, 4 microcoulomb and minus 6.7 microcoulomb. Two charges, 4 microcoulomb and minus what again there? Minus 6.7 microcoulomb are separated by a distance of 7 cm. Are separated by a distance of 7 cm. Comma. What is the electrical field? What is the electrical field at a point? What is the electrical field at a point P? At a point P, which is 2 cm. What is the electrical field at a point P, which is 2 cm from the 4 microcoulomb charge? P, which is 2 cm from the 4 microcoulomb charge. All right, let's get this done, please. I've said before, your best option is to always draw diagram. So first things first, they gave us two charges. I'll call it Q1 and Q2. Call the first one Q1. Please, Q1, how many, please? 4 microcoulomb. Here. Q2, how many, please? Minus 6.7 microcoulomb. They said from here to here, distance between them, how many? All right, so let me bring this down a bit. I'll bring this down. So we are here, this and this. Distance from Q1 to Q2 is about 7 cm. They said find the electric field. They can call it electric field or perhaps electric field intensity at the dim. They say at a point. What point? They say the point is what there? P. P is what there? So this becomes P here, such that P is 2 cm from what there? The Q1 charge. So I'm having 2 cm from here to here. From here to here. Distance here? Of course, obviously 5 cm. Please, from here to here is 7. So if here is 2, here has to be 5. I'm having 5 cm. They are now asking to find the electrical field or field intensity at this point here. What do you do? Very simple. First of all, find the electrical field intensity at this point due to this charge. Then add that value to the electrical field at this point due to this charge. So I'm saying, take that. Okay, copy this first. Copy this, please. Copy this, please. The total electric field intensity at point P, the total electric field intensity at point P would be equal to the total electrical field intensity at point P would be equal to the electric field intensity at point P due to charge 1, okay, hold on, will be equal to, use the word please, the sum of, please add it there please, the sum of, will be equal to the sum of the electric field intensity at P due to charge Q1 and will be equal to the electric field intensity at point P due to charge Q1 and the electrical field intensity at point P due to charge Q2. Due to charge Q2. So I'm saying that is E net. So E net means the net electrical field or the total electrical field is equal to E1 plus E2. E1 electrical field due to charge 1, E2 electrical field due to charge 2. Now it depends on how you want to solve this. You can choose to solve them one after the other or you can combine them. Let me solve them one after the other. I'll have that E1 is equal to what there? We said E is equal to what there? KQ1 over what there? R1 squared. What's R1? R1 is equal to distance between P and Q1. That's 2 cm. So it becomes 2 cm. Convert this to meters. Divide by 100. It gives you 0.02 meters. So I have this. So therefore, we can say that E1 is equal to K. K is 9 times 10 to the power 9 into Q1. Q1 is 4 micro 10 to the power what there? Minus 6. KQ1 all over R1 squared. R1 is this. That becomes 0.02 squared. So KQ1 all over R1 squared. Please give me value. Please give me value. What do you have? Nine times 7. All right, in Newton per coulomb. Please, is there a confirmation? Is correct? All right. All right. Let's get it. Let's get E2. Also, what's E2? E2 is equal to what there? K Q2 all over what there? R2 square. My task will be to get R2. What's R2? R2 is equal to distance between Q2 and P. That's what there? 5 cm. That becomes cm. Convert to meters, divide by 100 becomes 0.05 meters. So hence, we can say that E2 is equal to K 9 times 10 to the power 9 into Q2. Q2 is this one here, minus 6.7 times 10 to the power minus 6. That's micro, all over R2 squared. It becomes 0.05 all squared. Please give me value of E2. So E2 is equal to, what do you have, please? It should be a minus. It should be a minus. Minus 2 points. Sorry? Please confirm answer. What do you have? Minus 2, 4.12. How many? 6 Newton per coulomb. Okay? Is any confirmation this is correct? Who is confirming for us, please? So therefore, we can say E net, the total or the net electrical force is equal to, we said it's E1 plus E2, and that's equal to E1 is 9 times 10 to the power 7 plus minus 24.12 times 10 to the power 6. If I remove the bracket, it becomes, okay, it becomes 9 times 10 to the power 7 plus minus will give you minus. So minus this one here, 34.12 times 10 to the power 6. Plus minus is minus. So what do you have? Sorry? 65.88 10 to the power what? 6. So 6 what there? Newton per coulomb. Now check this out, please. 10 to the power 6 is what? That's what there? A micro. Okay, no, that's not micro. That's what there? Mega. Abi? Yes, the power 6 is mega. So that means E net, the net electrical force is equal to 65 point, perhaps you can use 9 approximately. 9 times 10 to the power 6 is a mega. So it becomes, sorry, okay, yeah. So this one is a mega. So this one is because what there? Mega Newton per coulomb. Please, this and this are the same thing. If you want to, you can stop here. It's okay. But I'm saying 10 to the power 6 has an abbreviation. That's mega. So it becomes mega Newton per coulomb. So that's how we solve this question.